Okay, we need to learn, now that we know what a polynomial is, we need to identify how to perform operations with polynomials. So in analytic geometry, we're required to know how to add, subtract, and multiply polynomials. So let's just take a look at that. We'll start with adding and subtracting. Adding and subtracting polynomials is much like adding and subtracting complex numbers. If you remember, with complex numbers, we had to put the real part with the real part and the imaginary part with the imaginary part. We want to do the same thing here, but we want to look for what we call like terms. So if I look at this term right here, it has a leading coefficient of 1. So this term is 1x squared. Now I can only combine that term with another x squared term. Their variables and powers must be the same for them to be like terms. So once I identify them, I've underlined them both in green, I'll say 1x squared plus 3x squared will give me 4x squared. If I'm adding or subtracting, I look hard for those like term endings, so they're definitely going to stay the same in my answer. And then those terms are taken care of. I have combined them, I've added them. Next I'll look at, let's get a different color here. This term is negative 4x. So I want to look for any other term that ends in x to the first. The other one that I see is negative 5x. And notice how I'm bringing that sign that's in front of the leading coefficient with that term, because it's a part of that term. So what I'm adding in my head is negative 4x plus negative 5x. That would give me negative 9x. And then I have successfully added that portion of the polynomial. Lastly, I have the term 7 left in the first polynomial, and that's a constant term, so I can only add any other constant term to that one. So 7 plus 8 would give me 15, and I have added those polynomials correctly. Now this is how we're kind of used to seeing adding and subtracting polynomials. We like for everything to have a buddy that I add with it. We like for everything to have a partner that's a like term with it. That's not always the case. Sometimes I can't just do these problems really fast thinking that everything's going to have a buddy. I really have to look for those like terms and those like endings. For example, look at this one. X to the first, I need to realize that x has its own exponent. So x to the first, y to the second. I want to check out any other terms that end that way. This term ends in x squared y to the first, so that's not the same. I can't combine it with that one. 5, this one's x to the first, y to the first, not the same as that one. This guy is x to the first, y to the second. They have the same ending. So this is a pair of like terms. I don't have any others that are like with that one, but I can combine it. This guy has a leading coefficient of 1, so this would be 1xy squared minus 10xy squared would give me negative 9xy squared. I search hard for the like terms. So remember that I'm going to keep them when I add or subtract. This is, let's get a different color here. I'm looking for any other term that's x squared y. This one ends in xy. This one ends in xy. So there's no other like term with that fella, so he is lonely, but I'll just bring him down with me. It's okay for him not to have a buddy. I can't combine him with something that's not like him. Done with him. And this is positive 5xy minus 5xy or plus negative 5xy, however I prefer to think about it. Those terms are opposites, and they leave me with 0xy. It's not necessary for me to put a 0 coefficient. That term wouldn't exist. Okay, in this expression, I've got a minus sign here in front of this set of parentheses. So I need to remember what might help me here is to go ahead and distribute that. This is telling me to minus 8x squared. And then distribute that minus, it's telling me to minus 5x to the third. I'll only flip what's in the parentheses because that's what the minus sign is attached to. So this will remain positive 7x and negative 10 or minus 10, however I prefer to think about it. All right, now let's underline some like terms. This first set of parentheses is in front of the minus sign, so their signs are not affected. I need to look for any other x to the fourth term. So as I do a quick scan, I don't see anymore. So this guy, I'll bring him on down. He doesn't have any buddies. So we're done with him. This guy is negative 5x to the third. And then I've got a negative 5x to the third again. So negative 5x to the third and negative 5x to the third will give me negative 10x to the third. And then those terms are combined. Notice how when I'm crossing out the terms, I'm very careful to cross out the signs that go with the terms. Let's try to keep this in standard form. I've done my x to the fourth, my x to the third. Let's skip ahead and look for x to the second. So here's a negative 8x to the second and a negative 8x to the second. Together that will give me negative 16x to the second. Now I'll go to my x to the first terms. So I have a positive 2x and a positive 7x, gives me positive 9x. And my only constant term is the negative 10. So I combined 2x and 7x to give me 9x. And then my constant term was negative 10, and that's the only one. He didn't have a buddy. And that's okay. All right, one more. Let's not distribute this time. Let's just use the minus sign like we know we're supposed to. Negative 2x squared minus negative 3x squared. Now let's think about those coefficients. I'm saying negative 2 minus negative 3. I can certainly use my calculator to help me with the integers, but that would leave me with positive 1x to the second. It's not necessary for me to put a coefficient of 1. Everybody's going to know it's there if I don't put it, so I'm not going to worry about that. That was my x to the second term. Let's look for our x to the first terms. Now, I remember I got a minus sign here, so this is 5x minus 7x. That leaves me with negative 2x. And I'm done with those guys. And then negative 3 minus negative 18. That's another one I need to be careful with. Negative 3 minus negative 18. That's really negative 3 plus 18, which leaves me with a positive 15. I forgot to underline them, didn't I? And that is adding and subtracting polynomials.